sequences a while back. Let's just recap that. When we write an arithmetic sequence or any sequence, keep in mind that it does start with 1, not 0, right? Linear equations all start with 0. Sequences start with 1, where this first term, the 5, would be considered our a sub 1. And then how it changed, that was called our common difference. Okay? Because we were adding 5 over and over and over. Now, your common difference can also be subtracting. All right? So we're going to open this up, and we're going to do a little recap here. An arithmetic sequence has a common difference. We use the letter D to represent that. It's kind of like our M, our slope. The rule for an arithmetic sequence is a sub n is equal to a sub 1 plus d times n minus 1. And remember, this n minus 1 piece is what lets you know it's a sequence, that it's not starting at 0. N is the term you're trying to find, a sub 1 is our first term, and d is our common difference. Okay, this is coming back to you a little bit. All right. We talked about before how you could distribute and collect like terms to get this to y equals mx plus b. So just to tell if it is arithmetic, tell whether the sequence is arithmetic. If it is, state the common difference and write the next term. So remember, if it has a common difference, then we're adding or subtracting the same value over and over and over. So -7 to -3 is what? +4, and -3 to 1. And 1 to 5, +4, +4. So is this arithmetic? Yes, it is arithmetic. What is our common difference? D equals what? 4. So if we continued this pattern, what would be the next term in our sequence? 13. Which would happen to be 1, 2, 3, 4, 5. This would be our a sub 6 if we wanted to give it a value, because it would be our 6th term. What about B? Is this arithmetic? How do we go from 5 to 22? And then 22 to 39? Oh, and 39 to 56? All right, so is this arithmetic? Yes, it is. What's my common difference? And what is going to be my 1, 2, 3, 4, my a sub 5? What? 73. Nice job. So hopefully this is jogging your memory. What about this next one? Is this arithmetic? No, because this is a +1 and then this is a +2. It's a neat pattern. It's just not arithmetic. And the last one, letter D. How do you go from 19 to 12? -7 and 12 to 5. -7 and look, oh, how nice. So this one is arithmetic. But now my common difference is negative. Is that okay? What's my a sub 6? -16. Good job. All right, so hopefully this is jogging your memory. How do we graph an arithmetic sequence? Well, first of all, this is my a sub n, which happens to be the same as y, right? So remember, way back when we talked about the first thing you need to do is make that table, right? Where this is my n or my x value. When you graph this, are we going to connect our dots? No. So here's 1, -5. Here's 2, -2. 3, 1, and 4, 4. But we're not going to connect this. Why not? Why is it discrete? Very nice. We have a list of points. Good job. So we're not going to draw that line. Now we've looked at patterns and we've decided if it was in fact arithmetic or not and found that common difference and such. But could you write a rule? Keep in mind, when we write a rule, we need two things. First of all, we need the first term, a sub 1. and we need that common difference. So what do you think? What's my a sub 1 in this particular practice piece? Negative 11, right? Because we're going to make our little table. 1, 2, 3, 4, 5, all that. So negative 11. What's my common difference? Positive 5. So when I write my rule, a sub n is equal to negative 11 plus 5 times n minus 1, where this is my common difference and this is my a sub 1. And this is important because this is going to help us figure out exactly any value we wanted. Maybe we wanted to know the 100th term, a sub 100. So I could put 100 here. I would use my calculator, of course. I would say 5 times 99 minus 11. Right? So you could use that for any term. What about b? What's my a sub 1 on b? 4. What's my common difference? 9. So what's my rule? A sub n equals what? 4 plus 9 times n minus 1. Good job. And this last one. A sub 1 and d. What do we get? 8 and negative 2. So what's my rule? Very nice. 8 minus 2 times n minus 1. So, nice little recap there. We feel pretty good about arithmetic. All right, so now we're going to change gears. If arithmetic is adding and subtracting, what do you think geometric is? Multiply, divide. Okay? Now, some of the same rules apply. We are still starting at 1 because it's still a sequence. All right, so we still have an a sub 1 here. But now, whatever we're multiplying or dividing by, this is called a common ratio. A common ratio. And we are not going to show division with a divide sign. Okay, so we'll address that in just a minute. Nope, not a star sign either. All right, so let's open this up and see what we know. So we just talked about this. Geometric sequences have a common ratio. We actually use the letter R for that. I know that R gets used for a lot of different things in math. When we did correlation coefficient, it was an R. When we did geometry in 6th and 7th grade, R was radius. Okay? But when we're talking about sequences, R is in fact that common ratio. We are going to write it very similarly to our arithmetic. We're still going to have a sub 1, but because we are multiplying, we're going to say times R, and n minus 1 is now an exponent. Okay, so before we had a sub 1 plus d times n minus 1, now we have a sub 1 times R to the n minus 1 power, because this is not going to be linear. Okay, and this is going to lead us into our practice tomorrow. So again, n is the term we're finding, a sub 1 is our first term, and R is our common ratio. So again, let's decide, is this geometric? What do you think about letter A? 2 to 8 to 32 to 128. Times 4. So this is in fact geometric. The R is 4. So what would be our A sub 5? What would be our next term? And you do have a calculator in front of you. I don't expect you to just, hurt your brain because we just got back from break. That's okay. 512. Because 128 times 4 is 512. Nice job. So do you see the similarities? What about here? 1 to 4 to 9 to 16 to 25. No. Do you know what this pattern does happen to be? Is it arithmetic?
No, but you add more each time. Like 1 to the previous one.
Yeah, this is squared. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. What about C? 81 to 27 to 9 to 3. It is geometric. Okay, we are dividing, but we can't write a divide. So if I'm dividing by 3, what is another way to write? Nope. Luke? Times, very nice, times 1/3. So that is going to be our R, times 1/3. So we're not going to have that divide. So 1, 2, 3, 4, what's my a sub 5 going to be here? If I have 1/3 times 3, I get 1. Very nice. And this last one, be careful. -3. 5 times a -3 is a positive 15. 15 times a -3 is a -45. Negative times a negative is a positive. Positive times a negative is in fact a negative. Good job. So what is my R here? -3, 1, 2, 3, 4, 5, 6. A sub 6 would be what? $215. Is it a positive or a negative? It is a positive. Good job. Any questions there? So a minute ago, I told you this was not going to be linear. So let's look and see what happens here. We're going to make our table 1, 2, 3, 4. So here is 1, 1. Here is 2, 2. Oh, it's linear so far. 4, 1, 2. I'm sorry, 3, 1, 2, 3, 4. 4, 1, 2, 3, 4, 5, 6, 7, 8. Bless you. Is this linear? It's still discrete because, like Chris said, it's just a list. But notice it has a curve to it. And that's what we're going to be looking at today. This last piece says we're going to write our rule. So again, you need your a sub 1, but now you need your R. So our a sub 1 is 2. What's our ratio here, common ratio? 6. So here is how it gets written because we need to practice this. A sub n equals 2 times 6. And your n minus 1 is an exponent. That's actually what we're going to learn about this in this unit is that's what gives us the curve. All right. Then what's our B? On B, what's our common ratio? Positive 3. So what's my rule? A sub n equals what? -5 times 3 to the n minus 1 power. Good job. And the last one. Careful here. 1/2 because we're dividing by 2, right? Good job, good job. So a sub n equals 80 times 1/2 to the n minus 1. Now you could also write 80 times 0.5. Be really careful. I would do 0.5 because as we've learned, sometimes our decimals look like times and we have to use a dot. All right, how do we feel about this? Pretty good? All right, I have a couple things I want you to do today. The first is fairly simple. It is a maze. I'm going to give this to you in a minute. You need to decide if it is common difference or common ratio and decide if it's arithmetic or geometric. So if it's arithmetic or geometric, you're going to color that in. And then you'll write in the box what the common difference or the common ratio. All right. And then after that, that's the easy assignment. Then we're going to work on this. I've got the pattern for you here. We're going to do some practice with this. All right. That is our goal. This is going to be due tomorrow.